everyone. So today we are going to talk about the power rule. So basically this is our shortcut for finding the derivative. So pause the video and do the do now. The graph of the function f shown in the figure has horizontal tangents at 0, 1. So here, 2, -1. And a vertical tangent line at 0.10. All right, so there. That's not it. That's -1. So right here we got a vertical. For what number x in the open interval is f not differentiable? So where is this not differentiable? So whenever there's a gap, so -1 and 1. -1 and 1. That's it. All right, so quick review of Pascal's triangle. So we talked about this recently, last week, I think. So remember, it starts with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, right? Because we're adding. 1 plus 1 is 2, 1 plus 2 is 3. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then a 1 on the end. So 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. So this is helpful because so we don't have to actually do all the work to multiply out. So we're going to look at our line 5. So this is line 0. Oops, why am I in marker? This is line 0, line 1, 2, 3, 4, and 5. So it's this one. Basically, the one with the 5 is the second number. So these are our coefficients. So I'm going to put in 5, 10. All right, I confused myself. So I'm just going to start from the beginning. So we start with a to the 5th. That's 1a to the 5th. And then 5. Now the a goes down by 1. And the b goes up by 1. And then we got the 10. So 10, a goes down by 1 to 3. B, and it goes from 1 to 2. 10, a goes down, b goes up. 5, a, b to the 4th. And then last, b to the 5th. All right. So if you notice, for the a's, it goes 5, 4, 3, 2, 1, 0. And then it's the opposite for the b's. It goes backwards. B to the 0, B to the 1st, 2nd, 3rd, 4th. All right, so that's kind of the pattern. Okay. Theorem. Definition of a constant function. If f is a constant function and f of x equals c, then f prime of x equals 0. If you think about it, if you have a horizontal line, what's the slope of a horizontal line? It's always 0. So if f of x is 5, f prime is 0. Anytime you have f of x equals a constant, -12, f prime equals 0. Oh, here's a good one. F of x equals pi. People like, because pi is a letter, it's like P in Greek, a lot of people are like, oh, it's 1. No. F prime equals 0. Pi is a number. Derivative of 3.1415, blah, 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 is 0. Okay. Simple power rule. All right, the derivative, this is a theorem. The derivative of the power function, y equals x to the n, where n is greater than or equal to 1, is an integer. Actually, that's not where n is an integer. Actually, this works when n is not an integer. The only time this doesn't work is if n is what? No, it works with a negative too. Pretty much this always works. So x to the n, the derivative of x to the n is nx to the n minus 1. So I'm going to go through and prove this for you. Okay, so I'm going to prove to you the derivative of x to the n, right? So x to the n, think of that like x to the 5th, all right? X to some power. So whenever you start to find the derivative, you start with the difference quotient, right? My limit, the definition of the derivative, okay? So now what I'm going to do, the hard part is, I'm going to make this yellow, is this piece. Oops, my pen turned off. So we have x to the h to the n, x plus h to the n. So the previous slide, that's why I showed that to you, because if you note it, because it's kind of complicated, right? X plus h to the n is this. So these are the same. So it goes x to the n, and then from the Pascal's triangle, these coefficients have like different numbers. So it goes down by 1, right? X to the n minus 1, x to the n minus 2, all the way down, and then the h, it's the opposite. So then next, we're going to put this back into the limit. All right, so now I have the limit. I forgot my h approaches 0. So I have, this is my f of x plus h to the n, right? So there's that plus dot dot, because I can't fill the whole thing in. So now if you notice what happens, remember whenever we did polynomials, we had stuff without the h canceled. So this x to the n at the back cancels with the x to the n at the front. And then notice there's an h in every single term. So every term we have an h, we have an h, we have an h. So all the h's then we get divided out. So that h cancels that h out. This one becomes h to the first, and that one becomes h to the n minus 1. Now that the division is gone, we can plug in 0. So when we plug in 0, so everything that has an h in it goes to 0. So that goes to 0. This goes to 0, that, and like all the things in between. So that our final answer is this. Right? So that's a proof. Would I ever make you do this? Absolutely not. It's just showing you why this works. So we have this fact, but what does it mean? Right? So let's think about what this means. If we have f of x equals x to the third, right? So 3 is my n in this case. So the derivative is the n is now in front, and then we take our n and we minus 1. So we bring the 3 down front, and then it goes down by 1, right? G of x equals x to the 13th. The 13 comes down front, 13x, and then subtract by 1, 12. That's it. Y equals x to the 8th. Y prime, the 8 comes down front. Put your x, 8 minus 1 is 7. Done. All right, so now we're going to go through. I'll do a couple of these with you, but hopefully from that last slide, you can be able to figure these out. So what's number 1? Do that one do number 1 and number 2 on your own. So f prime equals, the 7 comes down front, x, 7 minus 1 is 6. It goes down by 1. You can write f prime of x. I write f prime because I'm lazy and I don't like writing. It's just a common way of to drop the notation and make it easier. 14 comes down front, x to the 13th. Whoops. All right, so now this one's the tricky one. What's my exponent here? There's really a 1 there. So the 1 comes down front. What's 1 minus 1? 0. What's anything to the 0 power? 1. So whenever you have a linear x, it goes away. Think about the equation of a line, right? Y equals 3x plus 5. The derivative, y prime, the slope of 5 is 0. It's a constant. The slope of 3x, that becomes 3x to the 0, which is just 3. All right, what do you think we do if there's a coefficient? They end up multiplying. 3 is coming down front, right? 3x to the second, right? It's really 5 times 3x to the second, so it's just 15x to the second. But doing those two steps is silly. We just multiply. So negative 2 times 6, negative 12, x, bring it down by 1. G prime, 9, right? It's technically 9x to the 0, right? But anything to the 0 power is 1, so it's just 9. All right, sum and difference rules. So you are allowed, if you have things being added and subtracted, to just take the derivative of them separately. However, that is not true for product and quotient. We're going to spend a day or two on what if it's a product, what if it's a quotient, because those rules are totally goes out the window, right? But if you have adding and subtracting, you're just going to take the derivative of each of them on their own. All right, so what would be f prime for number 7? Pause, write your answer. So that the 2 comes down, 6x minus 8, and then the derivative of 2 is 0. G prime, 8 comes down front. All right, so we got the 8 times the negative 4, so negative 32x, 8 down by 1 gives you a 7. 3 times 5, 15, 5 down by 1 because it gives us a 4. And then minus the derivative of x is 1. Make that, like, especially when you're new to this, if you have x, f prime is 1. Just kind of like keep that in mind. That's like, sometimes it's one of those that it's so easy, it's difficult. All right, last page. All right, so take the derivative, f prime. So the 4 comes down, 8x to the third, minus 12x, I have 2 pluses, I don't know what that's about, plus 2. All right, so now f prime of 2, now we're going to plug in 2. F prime of 2 equals, so we got 8 times 8 minus 12 times 8 plus 2, 64 minus 96 plus 2, that's 66. Minus 96 is negative 30. Find the equation of the tangent line at 1, negative 5. So they gave me, so 1, right? So we need the slope at 1. So f prime of 1 is 8 minus 12 plus 2, which is negative 2. So then I'm going to make my tangent line, y minus my y value is negative 5, so plus 5. My slope, x minus 1. And then the normal line, so the normal line is the negative reciprocal. So instead of negative 2, it's positive 1/2. Y plus 5 equals 1/2 x minus 1. And that's it. There is your homework. It's kind of a lot, but I kind of want you to do this so many times it becomes like second nature. Like 2 times 3 is 6. Like I just want you to get really, really, really good at these and be fast with them.